If there's one thing that determines whether users love or hate their virtual desktop, it's the display protocol. In this lesson, we'll cover the 4 protocols every EUC engineer needs fluent knowledge of: Microsoft's RDP with RDP Shortpath, Citrix HDX built on the ICA protocol, Omnissa's Blast Extreme, and the now legacy PCoIP. We'll also cover the transport and codec concepts underneath all of them, and the latency and bandwidth budgets that separate a great session from an unusable one. Before comparing protocols, you need to understand the transport layer underneath all of them. TCP guarantees reliable, in-order delivery, which is perfect for a file download and exactly wrong for real-time interactivity, because a single lost packet stalls everything behind it until it's retransmitted. UDP has no such guarantee, but that's actually an advantage here. The protocol can prioritize a fresh frame and skip a stale one instead of stalling. Every serious display protocol built in the last decade layers adaptive reliability on top of UDP to get the best of both worlds. Standard RDP begins every connection over a TCP-based reverse connect transport, which is what lets Azure Virtual Desktop avoid opening any inbound ports on session hosts. RDP Shortpath adds a parallel UDP path on top of that baseline, for managed networks like ExpressRoute or VPN, and for public internet connections using stun and turn. If neither UDP path can be established, the session simply continues over the original TCP transport. Shortpath is a performance upgrade, not a hard requirement, which is exactly why it fails gracefully. ICA, the Independent Computing Architecture, is Citrix's original remoting protocol, dating all the way back to WinFrame. HDX is the modern technology and marketing umbrella Citrix builds on top of ICA: intelligent redirection, adaptive compression, and data deduplication. The transport piece that matters most for interactivity is Enlightened Data Transport, or EDT, a UDP-based adaptive transport used for ICA connections, playing the same role RDP Shortpath plays for Microsoft's protocol. Blast Extreme is Omnissa's protocol for Horizon, engineered to work well across a wide range of devices and networks. It can run over either TCP or UDP, using UDP when available for better performance under adverse conditions. It defaults to H.264 for video compression, with HEVC available as an option where client hardware supports it. Blast Extreme has fully superseded PCoIP as Omnissa's primary protocol, which brings us to PCoIP's current status. PCoIP was developed by Teradasai, acquired by HP in 2021, and was historically the default protocol for VMware Horizon before Blast Extreme matured. As of 2026, you should treat PCoIP as legacy. HP announced it will stop selling its PCoIP-based HP Anywhere product and Trusted Zero client hardware starting May 7, 2026, with support ending October 31, 2026. Only legacy Teradasai desktop access contracts run to October 31, 2029. Omnissa has correspondingly moved to end PCoIP support within Horizon itself. If you inherit a PCoIP environment, your job is a migration plan, not a reason to design new deployments around it. All these protocols have to compress a constantly changing screen into a video-like stream, and codec choice affects both bandwidth and quality. H.264 is the universal baseline, broadly compatible and hardware decodable on nearly every client device. HEVC generally compresses more efficiently at the same visual quality, which matters on bandwidth-constrained links or high-resolution graphical workloads, but it requires HEVC decode support on the client and adds encode overhead on the host, usually offloaded to a GPU. A general task worker fleet is fine on H.264. A GPU-backed pool serving CAD or media professionals is exactly where that trade-off starts to matter. Round-trip latency is what interactivity actually depends on. Every keystroke and mouse movement has to travel to the host, and the resulting screen update has to come back, so high latency from long geographic distance, satellite links, or an overloaded network path makes a session feel sluggish no matter how much bandwidth is available. This is why protocol engineers spend so much effort on transport and prioritization rather than just raw compression ratio. Bandwidth determines how much detail and motion the protocol can push through per second. A single office productivity session typically needs a fairly modest budget, but add video calls, multimedia redirection, or high frame rate 3D graphics and that budget climbs substantially. We'll come back to concrete bandwidth planning per workload type in Module 3's networking lesson and Module 5's Teams and multimedia lesson. The display protocol is the single biggest factor in whether a virtual desktop feels instant or feels frustrating. UDP-based adaptive transport, whether it's RDP Shortpath, Citrix EDT, or Blast Extreme over UDP, consistently beats pure TCP for interactivity, and PCoIP should now be treated strictly as a legacy protocol on its way out. In the next lesson, we shift from how pixels move to how user identity and personalization survive on pooled, disposable desktops, persistent versus non-persistent hosts, and the profile tooling that makes non-persistent desktops feel personal.